The broadcast is now starting. All attendees are in listen-only mode.
Okay, we'll start with the scoop fourth query with import. So far we are taking data uh, using a split by mapper. We are learning optimization. Okay, now suppose I want to compress this input file. Whatever data is extracted from RDBMS, we need to compress it. So it supports 6 different compression techniques. By default, compression which Scoop uses is a gunzip format .cz. Okay, so by default, and first we need to know why we're compressing it. What is the use of compression? So compression can give you two things. One, you can reduce space. You can reduce space of input file, right? Suppose I have 1 GB data. If I am using compression technique, I can get 700 MB or maybe 500 MB. So in MapReduce, we have seen this part, compression, types of compression in Hadoop, right? The same compression is applied in a scope also. So in MapReduce, there are 6 different compression techniques. The same thing I'm going to use here one by one. Second is speed up the data transfer. Speed up data transfer. Okay. So by default, it is using compression technique is gunzip, ZZ. And how do you know which compression technique it has used? So that file will have this extension. So we are generating part file, right? If you say gunzip, it will create part m000.gunzip. We'll see this example. Then if I'm not using anything, this is the by default. But how many different compression technique I can use? So I can use snappy. This is in the MapReduce side by default, right? Then deflat, then gunzip we are using anyways, bzip2, then lzo, then lz4. These are the 6 different compression technique which we can apply. And here it is very simple. You just have to pass one argument to compress the data, and that argument is your query is same whatever query we have submitted in previous classes. Here you're using argument hyphen compression. Okay, there is no space actually. Hyphen compression hyphen. It is coming from which package? The compression and decompression is coming from a package called codec. Compression, CO stand for compression, DEC stand for decompression. So hyphen compression hyphen codec, and then whichever format you want to use out of this, you can pass it to your compression codec value. Automatically this file will generate one data with this format. Let's see the by default one first, and then any one of it I will tell you. Other you can check with your parameter, because we are just using this parameter to get this. So two things: why you are compressing it, and second, how can it compress that record. So let's take some table from RDBMS. and I'll take table. I'll take table sample. There is no record actually. Let me take this dim customer. We have good records available here. Dim customer. Okay. So this record will be there in HDFS, but in compressed format. I'm using by default one first. So your query remains same. Scoop import hyphen hyphen connect JDBC MySQL IP address, right? So 192.168. You should check this, but for me it is same. So I'm directly using it. Username, password, and we were discussing, right, that in Google Cloud Platform in GCP cluster this scoop is not there by default. So I've tested it, I've installed and downloaded, so it is working for me. Just we have to download a scoop file and set in bash rc. That's it. That's a smallest step if you want to perform in, suppose I think many of you have some issues in this Cloudera, so you can test that there in Dataproc cluster also. We should not write this password, we should encrypt it always. Table dim customer, target directory, my dim1. I can give anything to this, and number of mapper, let's say I'll give 1. And we are not using any this one. We are not using any compression codec. So I will pass one parameter hyphen hyphen compression hyphen codec. This will allow me to pass any value out of this. Okay, but if I want to this gun zip, if I want to take this gun zip, I will say only hyphen hyphen compress. That's it. Submit. The rest of this step is same. It is going submitting to map reduce, input split, number of mapper. You know how to optimize CPU. And I'll recommend this part to you whenever you submit a query. Always go there and check this URL. Retrieve record 7. So whatever data is there, we can see that information. STFS, DFS, FNLS, my underscore dim1. Sure, Sapnil, I'll share that in the mail. It's a small, tiny step, well, 3 to 4 step and job is done. Okay, not so big a step because your Hadoop and other thing is already done there. So hardly 10 minutes it will take if you're setting it up also. Can we see this using cat command? Okay. So definitely you can see this, but you cannot understand it. And why cannot understand it? Because this data is compressed data. So who will understand this now? How can I read this data back? How can I see this information just like this? Because if I check my data here, I can read it, right? This data is readable. but we can't make any sense out of this data. So here, who will provide me? Again, let me write the flow. Okay, my data is coming from RDBMS. Somebody gave some answer, I think. Uh, Zcat. Okay, interesting. Zcat. So you think Zcat is there? Let me see first that Zcat option is there or not. RDBMS. Then RDBMS is taking this data to HDFS. Then this data is stored in HDFS, right, in form of compressed file. So we know there is another ecosystem, right? Hive is there sitting on top of HDFS as Hadoop ecosystem. We have this Hive part after Scoop, by the way. So Hive is reading this data. Hive is reading this data from here and decompressing it. Okay, so Hive has an option. Hive has an option to decompress this data using codec technique. Decompress this data because Hive is a warehouse, right? Hive is a warehouse, just like you're using ETL tool to extract this information from here to there. Hive is a warehouse management tool, so it will manage all your data information. Okay, and it will basically provide you metadata, table structure, because in Hadoop we are not getting any metadata, we are only getting data. So metadata will be provided by this warehouse management tool, and it is having inbuilt property of SERDI, serialization and deserialization. Okay, so serialization is like converting your object into byte stream, and then deserialization is just a vice versa, converting byte stream into object. Why we use this all serialization, compression, encryption technique? To to make a file format which can be readable from multiple programming languages. Okay, because what is their problem in many programming languages, they specify that we can read only this. So if I use this serialization technique, my data can be readable from multiple programming languages if I want to manipulate with them. Okay, so we'll see that part in Hive, how can we do this all serialization, deserialization and decompressing part. But currently if you're thinking how can I read this data, in HDFS you can't read this directly, you need Hive to read this information. That is the reason this Hive is there working in any organization. You pick any name, any company who are working with Hadoop, they definitely work with this Hive, which is developed in 2010 by Facebook. So Facebook product this is. They donated to Apache and this became open source today. So can we see, okay, you're suggesting me to use gcat command. Let me see, do we have, so whenever we have such question, okay, we can use this HDFS DFS option. And if we can find any zcat, we can use it. But I doubt we have any zcat command here. No, it's just a cat command. This is like a help button, help suggestion box. Any information if you want to collect it, you can check it from here, that how many command you can apply after HDFS and DFS. Okay, anyway, so this is data stored in gunzip. And how do I know? Because my file format is having .zz. Suppose I want to take the same data. Suppose I want to take the same data and I want to apply this time different compression technique. I want to apply compression codec and snappy. Then we'll change this to mydim snappy. Enter. Uh, what happened? Okay, sorry. This is compression codec. This is compression codec. 7 records retrieved again. Can we see the time total? So this transferred data is 266 bytes, and this is 35.174 second. Okay. If I go and check the previous one, it is giving me 240. One second, where is the command? Yeah. So it's giving me 224 bytes in 40.1702 second. So 224 bytes is total data, 40.17. Here 266 bytes. What do you get? Why I'm doing this? Okay. So I'll recommend again to check for all this compression technique. You personally check in your machine all this compression technique and tell that which one is good in compression, because currently you're compressing it, you're not decompressing it. Okay, remember this part, you are not doing it currently, you are just doing compression. Now if question comes out of 6, if question comes out of 6 compression technique, okay, which one is a faster, which one is the faster means in less time. So in less time, if I check, you can actually achieve, if you remember guys, in MapReduce we have seen two things. Using this compression technique, we are achieving space and we are achieving speed. So please revise those videos, okay, if you're unable to connect this, because in compression we have seen this, that we can achieve space and speed. And there was two flag space, for space there was a flag -9, and for speed there was flag -1. This is what it is saying. This 266 byte taken by Snappy. Okay, let me just compare with this too. 266 byte taken by Snappy byte, and Gunzip is taking 224 byte. Their total time is 40 second. Their total time is 35 second. Sorry, I just wrote opposite. Their total time is 35 second and their total time is 40 second. So what did you get it from this two file? That space is more optimized in gunzip format, but they're taking more time to process in CPU. I'll tell you the reason behind this, okay? But Snappy is taking more space, but their time is faster than gunzip. So I can conclude in my observation, Snappy is more faster, but space wise this is taking more. Gunzip is slower, but space is optimized well in Gunzip. It depends on your application. Suppose you're working with a microchip or IoT devices, then you'll think that you need a space better or you need a time. Always your whole programming from beginning 1990s or 1970s, when people started working with a Haskell and other thing, only two was major problem in programming languages. One was time and second was space. So this is known as a time and space complexity or trade-off. That how can we, because over the period of time, if I just give you one explanation on this space is for RAM. So let's go to deep dynamics of it. Okay, this is for RAM and this is the time, unit of time, how much time this is taking. Now in unit of time we have not achieved uh, much faster unit, but space we have achieved, right? You are seeing yourself that over the period of time this RAM capacity is increasing. This is, I think, if I remember correctly, I have worked with a floppy disk of 128 MB also. This is in somewhere 2004 and 2006. And then we grew from this number to this number, from 512 MB. We started working with 1 GB, then 2 GB, then 4 GB. Nowadays, I think 4 GB laptop is ideal, right? They stopped making 2 GB laptop. Now, in future, maybe after 1 year, you see that there are company who are only creating 8 GB. You have personally 8 GB also in your machine. Then 16 GB many people are using. Many are using 32 GB if they want to create the multi-node cluster or production cluster in their machine, right? But why we are not buying this machine, higher configuration machine today? Just because we have cloud things available now from Amazon, from Google, from Microsoft, and we are using these services just to get this number. So over the period of time, since this is increasing, but this time has not increased, that's the main problem. Because when you're taking data, how much time that they are taking to complete the process, and that is why there are data structure algorithm. There are, in college time, you must have remembered data structure algorithm. And data structure algorithm is into binary search, sequential search, hash mapping functions, then list comprehension, list one list to another list searching. This is all based on this data structure algorithm. So I'm not saying which application is more better. It always depends on your application, what this application is talking about. Okay, so two things. Always do this analysis from your end. Check करो किसमें कम time लग रहा है, and write one observation. Just write, make one notebook and write there. Okay, this is good, this is faster, this is taking less space. And always remember one note, guys, because when we go to a Spark, this is very important. Okay, in fact, in some facility operation of Hive also, uh, if data is compressed, if data is compressed, so you are achieving definitely space, that's good. But if data is compressed, your CPU takes more time, your CPU takes more time to read and analyze them, to read and analyze or process them. So if you give me one data which is text data, and second if you give me compressed data, and if you ask me which one will be faster from the CPU perspective, I'll say anytime text data is more faster than the compressed. Okay, so just we're not using any by default thing and we don't know why to use it. First, always we should be clear with why part, how we're doing this. Can we try one more technique and then we'll compare with this again. So one last compression technique I'm using. Other I will suggest you can use one by one. Let me use this to LZO, and I'll change this to LZO, and then I'll compare time and space again. What it says, cannot find compression LZO. So maybe I think we'll have to hit client jar. Let me try with LZ4. We'll see this error. Okay, why this is coming. This is maybe dependency of jar file. Okay, this is taking the highest space, right? So far we have checked our Snappy and Gunzip. So Snappy was 266, Gunzip is 224. This is taking 272 byte. Space is more, and 34.7499 seconds. This is the highest performing time in LZ4. So do this comparison and then reach to the conclusion which is faster. You can get this information, by the way, from page number 5, that book which I talked about, O'Reilly Definitive Guide. After compression technique, we'll go to see how many file format we can use, right? So we've seen that. How do we have any other delimiter when we're extracting data apart from text delimited? So we have multiple file format. In a scoop, scoop supports 4 file format. By default is a text again. By default is a text format. So in MapReduce also by default input was text input format. Other than text, first one is sequence file. Now why we are using file format? For encryption. Why we are using file format? For encryption. Okay, encryption is mainly for data security. Okay, data security it provides us. And second thing, encryption file can be readable from multiple programming languages. So it's like I'm encrypting this, or I can say I'm in another word I can say I'm serializing it. Sequence file is one format. This is good for a file which are in binary forms, right? Like uh, suppose I have images and I want to use that images in Hadoop. So image can also be stored in Hadoop, right? Hadoop can handle any types of data. So sequence file can be good for images. Then Avro. Avro is the AVRO. Avro file format. And third one is a Parquet. So Avro and Parquet is very useful in Hadoop nowadays. Okay, this is very used. Sequence I have used seldom, not often, but Avro and Parquet we are using frequently. Mostly we are using Parquet. What is the difference between Avro and Parquet? So Avro file is, this is the serializing of your file in row basis. So this serialize your file on this format like row basis, and this is a horizontal operation. So when you are taking data from RDBMS, right, just like the way we are doing, when you are taking any data from RDBMS, Avro is better. Avro is more better. But when you're storing this data to Hive in warehouse, or maybe you're storing in NoSQL database, Cassandra, MongoDB, HBase, right? So Parquet is more better because Parquet works with the column basis serialization. So this is a row basis serialization and this is a column basis serialization. So difference between Avro and Parquet can come. What input I'm giving, so this input I will pass directly in my file. My query is same again. My query will be same. I will remove this compression codec and use one file format as, one second, I'll say here hyphen hyphen as sequence file if I want to use sequence. And let's change this to SEQ. Hyphen hyphen as hyphen sequence file. Enter. Seven records, bytes. You can see 34.883 records. So Can I go and see this output? My dims seq hdfs my dim seq. This is a smaller s part file, but definitely this is this is taking more space, right, if you compare with previous one. So deep study, if you want to do, you can read the difference between encryption, compression, and deserialization, when to use what. Okay, this is the data, sequence file data. In sequence, they have uh, serialized your information, and this is how you can see it. Again, if you're thinking, how can I read it? Again, Hive will read this. In Hive, we have a file format to read this information. Can I use Avro technique now? So here it is, Avro data file, I guess. Let me try this. And this will change to AVRO. Password is root again. Size is even bigger than sequence. I think almost double. My team Pro. Primary key concept is same, Swapnil. If you need a primary key, if you want to extract data, right? So primary key concept is similar, that if you don't have primary key and you want to use multiple mapper, you'll have to use split by. That is one option. Condition of primary key and split by is same applied for whole scope, not for compression or file format. That is the reason I talk about split by and primary key first. So if you have a primary key in table, you can use multiple mapper. If you don't have primary key, still you can use it, but you'll have to apply split by in that case. So part M0000.avr extension, you can see, right, clearly data is there with this extension. That if I am confused, like which format it is using, so we can use this ls command first to see the information, then we can cat it also. Yes, if you well, you will not face this problem in real-time production, but interview they can ask you, like how you handle if data is very high in maybe GBs or TBs, and that table does not have a primary key. So how can you handle the parallel computation? Then you can say that I can use a split by. But in real-time scenario, your RDBMS production table will be having definitely a primary key, because without primary key, we don't create a table in production boxes. Okay. So the answer is in another ways, right? If you're thinking, if I don't have primary key, can I use a split by? Yes, you can use a split by. Now this data is there with metadata, right? Can you see it? This is Avro file is having a property that it is giving me schema also, Avro schema. So one good point here that it keeps the data and metadata both together. So if I'm reading this file in Hive, it makes easier for me. I can download this Avro jar, take out this schema in a JSON format, okay? And then while creating the table in Hive, I can pass this schema. I'll do that part in Hive. When I go to Hive, we'll read the same information again, and we'll see how we can Hive locate this. But currently, if I read, this is giving me type record, name is dim customer, doc, scope import of dim customer, fields we have, right? So these are the fields then. This data is pretty much in JSON format, JavaScript object notation, and if you know JSON, it's a semi-structured data type. And this is my column name, guys. Column name, customer ID, uh, customer alt ID, customer name, then gender, then load date, right? And then table name. This is all schema, and this is the data. This part is the data part. Some information, still I can see some information, right? Like Kentucky is there. Still this is visible. Kentucky is visible. Richard Trubin is visible. I can read this data. Muskan Sheikh is visible. I can read this data. So that is why we call JSON is a semi-structured data type. Semi-structured का मतलब ये है that some data we can read, some data we cannot read. Like if I say in plain English. This is for Avro and Parquet के लिए I'll just need to pass Parquet. It does not take this uh, target directory. And where is this all script written? This is all in scoop bin directory. So scoop bin import is calling one by one and taking this information. So for Parquet, what I will use, I'll say hyphen hyphen as hyphen Parquet file. Parquet file. This is an again in book. If I want to read theory of Parquet and Avro, this is in chapter number 16th and 17th. Parquet and Avro both. It's a theoretical completely. So read it. If you find uh, any confusion, any problem, you can let me know. But one single line difference I have told you that this is row basis serialization, this is column basis serialization. Whenever you are taking the data from RDBMS, Avro is better. When you're storing this in NoSQL, Parquet is more better. Uh, 39.8749 second. And why the file size is bigger here, I will tell you. Because this is separating and storing metadata, and this is separating their data. Just like in Avro, data and metadata both are together. Here it is different. And that's why your file size is even bigger. So there is a logical reason. It is going in inside user cloud era because target directory we have not defined. Dim customer, right? This is the today's date. You can see it. This is based on my system date. think today's 6/12, but you can see my system date is this. This is my data. Now if I go and read this information, HDFS minus ls user Cloudera dim customer. Target directory you can't define, Swapnil, because this is in a script, right? If I define a target directory, I will do that for you. After reading this data, if I pass it in scoop script, it is written that by default it will go and take this data append in this directory only. I'll run that target directory, it will fail if I pass target directory. So this is the metadata folder, okay, and this is my actual data. The last one is my actual data. So if you see the last one, it is having .parquet as extension. Okay. So can I see first metadata? This will again have a AV. The metadata format is same as AVRO. Well, it's a JSON data. Okay. So if I read this AVSC file, schema.avsc, get this. So this is your table structure stored in JSON. This is having the separate file. Can we check this schemas? What are they? It's creating one AVSC. Okay, so they gave you basically, I think there is any difference between these two. Record, they gave two schemas. One is stored inside .metadata schemas folder. Within schemas, we have one .avsc and one directly the file schema.avsc. You can pick up anything. Okay. Then yes, why target directory is not defined? Can you see the data first? Before checking target directory, I'll copy this address and read it from here. dfs minus cat. This is my data. These are my information. Okay. Now let me change the query and pass target directory. So as Parquet file, and after table, hyphen target hyphen directory, and the directory name is dim underscore Parquet. So what is the error? It says data set not found exception, unknown dataset URI pattern dataset HDFS. Okay, why this is coming? One plain reason that in a script it is written. So in which script? Inside user lib scoop bin. If you open this scoop import, we are so far doing this part, scoop import. So this target is already defined. Now, if you want to change this, then you will have to create your own scoop tool. If you change this existing configuration, maybe your Cloudera can be start behaving differently. So this is already configured. That is the reason we are unable to do that. But if it is my own tool, right? If it is like my customized cluster, and it's like I'm creating my own scoop tool. I'm not using ready-made one. Then I have this option to do, but not for this case. So we know this two technique, Parquet and Avro. Will be using extensively this two file format in Hive, also in Spark also. Spark also uses Parquet file format heavily. Okay, so difference we should know, guys. Or technique, one technique is okay. You know that in compression you're using this, or file format you're using this, but difference between both, and especially if I am working in an architecture level, like I'm a principal architect and I'm defining the project flow completely. So I should be having this full information, because business can ask me anytime that why you are using this, why not this. So we should be able to give a befitting reply, right, to them, that what data you are giving me, it is best fitting with this information, and hence I'm using it. All right. So after this, compression, decompression, and file format, decompression will do in Hive part. We have another operation as null encoding. So I can encode the null value, because when I'm extracting data from this, or let me see, any table which has null record, customer ACC, I think, customer ACC. Here we have some null record, right? In some string column, and in some trans p n column. There is no string column actually. Let me take other table. Txn. So I'll do this intentionally, one entry as null. Insert into txn values. Okay, txn values, and I'll pass here value for CID is say 101. Item I watch, that is a string, and I'll say null in place of it. Then price is $400, and transaction ID is some 900. One entry for this string column, and why I'm doing this I will tell you just in a while. 102, maybe 105. Then this has some actual record, which can be a laptop or lap, because character I have defined till 5 only, I guess. So lap and lappy also I can say. 400, instead of 400 I will write null again. Okay, null is a keyword in MySQL, by the way, and this is 1000. Why I'm doing this? Select a star from table name. So we have two null records available in MySQL. Now, if I take this data in Hadoop in HDFS, what will happen? This is last query for today. What will happen? This record will go to HDFS for sure, but this null will be written here like null. So this row will write in a file like this: 101 null, 400 and 900, and 105 lappy null and 1000. Now I want to encode this null value. And to encode this null value, there are two arguments in scoop. One is hyphen null hyphen string. It says whatever string column you have in your MySQL or any RDBMS table. I'll repeat, whatever column are having a string data type, if you have any null data there, you can encode actually here with any value. I can write only n here. So within single quote, I can write anything. I can write even my name also. So I can write this also. Right? It depends on you what value you want to pass here. Okay. So suppose your entry is wrong there, but you know the actual record. That can I encode this value as uh, headphone null string? Wherever it has a null string, can I encode this? So I can pass this value. Okay, let me use this headp. So this null value will be encoded in HDFS, and null will not be there. Instead of this null, the first null, it will place it as headp, because this null is which column? Item column. And what is the data type of item column? It's a string or varchar. So both are same thing, right? String, varchar, char, they're coming from the same family. Now one parameter is this, second parameter is applied for all value other than string. So this is null non-string, and I can give here some value. Let's say I can give here a $30.00. So when I pass this two null value will be encoded with these values. So this is applied only with a string. This is applied other than string. If it is double, if it is float, integer, if it is date column, timestamp column, it will apply with all. So you can pass this value, or you can give some generic value like n. That is up to you. So can we see this practical in indirectly there? I'll pass for both null and null non-string. Okay. My query remains same. I'll just change my table name, which is txn table. Target directory null encoding txn. Okay. Parquet file and all we have seen, so no need to write it now. Target directory this, and one parameter I will pass after table name: hyphen null hyphen string, and let me write here headp, the value which I'm expecting, and then hyphen null hyphen non-string. Here I'll pass a value such as, what was the value? 30.00. You can pass any value, guys. I'm just taking one example like this. Okay, this is not there, and submit this. Give a password as root. So this is encoding for your data. You're doing kind of transformation, right? You're changing the value using a default argument given by a scope. extracted 163 byte, very less information. And we'll go to this null enc txn, null enc txn, and part file. So to read this part file, this is last 2 is your data, head p, and so this was null, this was null, and this was null. Encoded the data and extracted in this. So uh, 4 to 5 other queries are pending in scope. Hopefully we'll see that tomorrow.